Buenas noches, good evening, everybody. Welcome to day 2 on week 12 of the semester. In today's class, we are going to be reviewing important material for exam 3. Exam 3 is going to be this weekend. Remember that it opens tomorrow at midnight, and you will have until Sunday at 11:59 to submit it. Remember to log in on time because the exam, similar to the other two that you have already taken, is going to close on Sunday by 11:59. So please start the exam 3 before then. If you didn't receive a message from MiraCosta College, I just want to remind everybody that I know that we have this exam, but next week on Friday, November 18th, is when students have to make the decision if they want to keep the class or they want to withdraw. If you choose to no longer be in the class, please reach out to me. I'm more than happy to talk to you and figure out how I can help you. But if you decide that you want to withdraw, by next Friday, the grade that will show up on your transcript will be a W. After November 18th, then I must give you a letter grade. So for those of you that are like, okay, I don't know if I want to keep the class or not, make sure that you make your decision by November 18th, which is next week on Friday. That being said, when it comes to exam 3, we are going to be having a section of chapter 5, which you can see is section 5.5. Then we have the material for chapter 6, which you can find here in the outline. Then we have chapter 7 material, but only section 7.1 through 7.5. So at this time, I want to at least review the chapter 5 chemical reactions, specifically the different types of organic reactions, which in the study guide, the last pages of the study guide, I give you a summary of the different types of organic reactions. When it comes to them, as you can see in the outline, you need to know the functional groups that are used and the ones that are formed, okay? Specifically, we have condensation reactions, hydrolysis reactions, oxidation reactions, reduction reactions, and lastly, addition reactions. Specifically for addition reactions, which are the ones on letter E, you also need to know how to predict the product of an addition reaction. What does that mean? That if you are given the reactant and the reagents, for addition reactions, you need to be able to come up with the product. Remember that the exams are going to be different choices, but you need to be able to recognize structures in order to accomplish that. So let's get started with reviewing the reactions in chapter 5. Chapter 6 and chapter 7 material, I'm going to open the floor for any questions, but then after that, we're going to proceed to go to the Kahoot to review the material. So let's get started looking at reactions. So as I mentioned in the study guide, there are specific 5 types of organic reactions that you guys need to be familiar with for this exam. The first category, which you guys see here, and I'm about to highlight, is going to be condensation reactions, okay? And when it comes to condensation reactions, understand that you're going to have 2 functional groups that are going to come together and they're going to produce or they're going to yield 1 functional group. Understand that the 2 functional groups that we have in the reactants are going to be different from the one that you're going to produce in the product. Because overall, what we're doing in a condensation reaction is that we are gluing together the two functional groups that we have in the reactants to make that single functional group in the product. So when it comes to the condensation reactions that you guys need to be familiar with, number one, we have what is called an esterification reaction, okay? In an esterification reaction, as you can see, you're going to have a carboxylic acid combining with an alcohol. This is going to be in the presence of an acid catalyst, okay? The acid catalyst, how it's going to show up is that you will see H plus catalyst, or you're going to see strong acid like H2SO4 as a reagent, okay? This reaction also requires heat. So if you see any combination of H plus catalyst or strong acid, and then you see the heat, okay? Understand that in an esterification reaction, that carboxylic acid and alcohol are going to form an ester. And you can see it right here. Now, you may notice that when we see the reaction itself, you see the formation of water, because water is not an organic compound because it doesn't contain carbons, okay? Where is that water actually coming from? Well, to be honest with you guys, the water comes from the OH in the carboxylic acid combining with the H in the alcohol. That's where the water comes from, okay? So in esterification reactions, you may or may not see water as a product. The main thing that you have to remember here is that when it comes to this condensation reaction, again, carboxylic acid and alcohol will form an ester, okay? Secondly, we have another type of condensation reaction, and this is called an amidation reaction. In an amidation reaction, we're going to have a carboxylic acid combining with an amine. So if you go back into chapter 4, thinking about the functional groups, okay? Carboxylic acid and amine, understand that this reaction also requires heat, okay? So here you see that line H2O. That means that this, what it means is that you are losing water in the reaction, okay? So overall, similar to esterification, technically you could see it as minus H2O, or you could see it as the formation of the amide, which that's why it's called amidation. And you may see the water in the product. So esterification and amidation are two reactions that will produce water when the reactants, okay, combine to make that functional group, okay? And those are the only two condensation reactions that you need to be familiar with, okay? Any questions on the two condensation reactions that you guys need to know and the functional groups that are going to be combining to make that product? Okay, put a 2 in the chat if you're ready for the next type of organic reaction. Excellent. In the next type of organic reaction, what we have is called hydrolysis, okay? And hydrolysis, in essence, What it means is that we are going to, quote unquote, cut with water. Now, I didn't go in depth into hydrolysis. Understand that the ones that I'm illustrating here is that water is going to be cutting a functional group, okay? And overall, we need acid. Understand that if you have to take other chemistry courses, you will be observing that hydrolysis can also happen with base, but the ones that I'm illustrating here specifically are with acid, okay? Now, when we have hydrolysis of esters, okay, because we are quote unquote cutting with water, you will see water in the reactant with acid, okay? So H plus H2O, that represents water with acid. H plus H2O is also H3O plus. That's why when you see the second hydrolysis that we have here, you will see the H3O plus, okay? Now, hydrolysis actually requires heat, okay? But if you see H plus H2O or H3O plus, those are the reagents for the hydrolysis reaction, okay? Now, in the hydrolysis reaction in general, we're going to go from one functional group for the examples that we have. And then we are going to form two functional groups. Okay? And we can see here that we have the hydrolysis of two different functional groups. The first one is hydrolysis of esters. So when we are hydrolyzing an ester, again, under acidic conditions, meaning that we have this H plus and H2O, or we see that H3O plus, our ester specifically is going to form a carboxylic acid and an alcohol, okay? So hydrolysis of an ester is going to be the opposite of condensation to form an ester. I hope that you guys can observe that. Then the other example that we have, other than the hydrolysis of an ester, is the hydrolysis of an amide. When an amide is hydrolyzed, okay, understand that this is going to start with an amide. And in terms of functional groups, we are going to have a carboxylic acid, and we're going to form an amine. Now, that amine, you may notice that when it comes to its structure, it may look like it has an extra hydrogen. I know that so far in the semester, we haven't talked about acids and bases because that is going to be coming in later chapters, but just understand that that amine you will be recognizing because specifically you're going to see either ammonia, which is NH3, but if it's protonated, it's going to look like NH4. Or if you have any other amine, remember that that R group, what is representing is a chain of carbon atoms. But it is important to note that at least because these are acid hydrolysis, these are the functional groups that are going to be formed. Any questions when it comes to hydrolysis? Put a 3 in the chat if you're ready for the next reaction. The next reaction type that we have is an oxidation, okay? So oxidations are the easiest to spot because when it comes to the reagents of oxidation, at least I want you to understand that the most common way to express the reagents for oxidations is going to be an O in brackets. Immediately, if you see something in O in brackets, that means an oxidation, okay? When it comes to organic chemistry, remember that oxidation means that we are going to increase the number of bonds to oxygen in a molecule, and we are going to be losing hydrogens, okay? The first reaction that we have here is the oxidation of a primary alcohol. And in the oxidation of a primary alcohol, and let me remind you that a primary alcohol is going to be an alcohol molecule in which the carbon atom that is connected to the OH is bonded to one carbon chain. That's what makes it primary. So when a primary alcohol is oxidized, the functional group that we're going to be making is an aldehyde. Okay. As you can see here as a note, if you don't see O in brackets, you may see this PCC, and PCC is just an oxidation reagent, okay? Now, if you have an aldehyde, okay, like you see in the second reaction, when we have an aldehyde and an aldehyde is oxidized, that's going to form the functional group called carboxylic acid. So it is crucial that for this exam, when you are recognizing the different types of reactions, you know specifically the different functional groups that are there, okay? Lastly, we have the oxidation of a secondary alcohol. And remember that what makes a molecule be a secondary alcohol is that the carbon that is holding the OH is bonded to 1 and 2 carbon chains. That's what makes it a secondary alcohol. And a secondary alcohol, upon oxidation, is going to make a ketone. Glad to hear that this is very helpful. Just remember, when it comes to these, this is like at least intimidating for some students just because they see molecules and they're like, oh my God, what is that? Just focus on the functional groups, because in this course, we didn't actually experience much the prediction of the products. It's only in the addition reactions, which we're going to do in a few minutes. But it is important that you guys do pattern recognition, meaning, okay, what do I have in the reactant? What reagents do I have in what functional group am I going to form? You guys are able to do this. I believe that you guys will be able to do this, okay? Any questions on oxidation? Then put a 4 in the chat if you're ready for the next type of organic reaction. The next type of organic reaction is called a reduction, okay? And overall, what's happening in the reduction is that we are in a way, we're going to be having in our products less bonds to oxygen, okay? So in essence, we're just going to be adding hydrogens specifically to the oxygen in the carbonyl and the carbon in the carbonyl. Each of them will get 1 hydrogen, as you can see here, okay? Now, it is important to note that whenever you guys are observing reduction reactions, there are different reagents for specifically reduction reactions. So those reducing reagents that will be able to accomplish these transformations in terms of functional groups include NABH4. The other one that can accomplish this is H2, which is molecular hydrogen with catalyst. And lastly, we have LiAlH4 with water. That is the other reagent that can accomplish this. One of these, it doesn't matter if it's the NABH4 or the H2PT catalyst or the LiAlH4, which is that's lithium aluminum hydride. It doesn't matter which one is used. All of them will accomplish the same thing, which is if you start with a molecule that has a carbonyl, then the oxygen in the carbonyl gets a hydrogen, the carbon in the carbonyl gets a hydrogen, okay? So let's look at the first reaction, which is the reduction of an aldehyde to a primary alcohol, okay? So we start with an aldehyde. And once my oxygen in the aldehyde gets a hydrogen and my carbon in the aldehyde, specifically in the carbonyl, gets a hydrogen, what I form is a primary alcohol. Then we also have specifically the reduction of a ketone. What happens when a ketone is reduced? Similarly to what we saw in the aldehyde, the oxygen in the ketone gets the hydrogen. The carbon in the double bond oxygen, remember that these changes are only happening at the carbonyl. Let me highlight the carbonyl. So this is the oxygen, the carbonyl, that's the carbon in the carbonyl, so this group. So again, the changes are happening here at the carbonyl. They are the ones that are getting the hydrogens. When that happens, in the case of a ketone, what we're forming is a secondary alcohol. Notice that any of the reactions that I have talked about does not change the number of carbons from the reactants to the products. All we're doing is specifically creating more bonds to oxygens or creating more bonds between carbon and oxygen with hydrogen. So please pay attention to the functional groups, okay? Any questions on the reductions of aldehydes and ketones? Great. Put a 5 in the chat if you're ready for the last one. Excellent. After class today, I will be uploading all of these notes that you see here for the reactions, specifically at Canvas. So at least you guys, if you miss anything, you can go back to the notes and observe them. So the last type of reactions that we have are called addition reactions. So in addition reactions, we are going to have 2 different types of addition reactions. The first one is called hydrogenation, okay? And if it's hydrogenation, what are we going to do? We're going to specifically add hydrogen to the functional group that we started with, okay? Now, When it comes to hydrogenation, understand that we can hydrogenate an alkene or we can hydrogenate an alkyne. Any of those two. Now, what happens when I hydrogenate an alkene? Well, let's pay attention. The carbon that was double bonded will become single bonded to them. And then if we pay attention to what's happening overall, the reason why these are called addition reactions is because we're going to add atoms across the double bond or triple bond. So in the case of an alkene, we are going to make an alkane because here, each of the carbons that used to be double bonded are going to receive a hydrogen, one each. Okay, so we go from alkene to alkane. Whenever we have the hydrogenation of an alkyne, the hydrogenation of the alkyne, because we have a triple bond to start with, is going to require more hydrogens to be actually added to where the carbon-carbon triple bond was. So if the carbon-carbon triple bond is here, okay, we can see that these two carbons that I highlighted in magenta are the carbons that used to be triple bonded to one another. Now, notice that for alkynes specifically, whenever it comes to how many hydrogens am I going to attach to the carbon that used to be triple bonded in this case, we need to attach a total of 4. That's why you see an H2 right here and an H2 right here. So for alkynes, you require 2 moles of that molecular hydrogen, because overall, if we look closely, we can see that each of the carbon atoms in the alkynes must receive 2 hydrogens. So because there's 4 H's here in essence, this carbon will get 2 H's. That's why you see the CH2. And this carbon atom will get 2 H's. And again, which are the carbon atoms that receive the H's? The ones that used to be triple bonded to one another. So similar to what we saw in an alkene, the product of the hydrogenation of an alkyne is going to be an alkane molecule. And remember that that alkane molecule is not going to change the number of carbons. The last type of addition reaction that we have is going to be hydration, okay? And in the hydration reaction, similar to what I mentioned to you guys before, we need water, okay? Oh, I see that H2O, let me fix that. I think the O is not there, but let me write it in. So we need H2O and acid as a catalyst, which you can see that it can be shown as H plus or H2SO4 because that is a strong acid. Now, remember that the reason why we have catalysts in many of these reactions is just to increase the rate of the reaction. That's about it. That's the only role that they have there. Now, when it comes to hydration, understand that we are always going to start with an alkene. I never in this class mentioned to you guys what happens to hydration of alkynes. We never study it. It's not going to show up in the exam. But we did talk about hydration of alkenes. Now, overall, understand that when an alkene is hydrated, okay, with those reagents of H plus and H2O or H3O plus, the other one that we can also have is H2O, comma, H2SO4, that they all mean the same thing. H2O plus. That also means H plus, comma, H2O. They all mean the same thing. So in a hydration reaction, what we have is that we're going to form an alcohol. In the first example that we have here in the alkene, when we pay attention specifically to the carbons in the alkene, they are directly attached to the same number of hydrogens. Okay, so the alkene, the carbon on the left is directly attached to 2 hydrogens. The carbon on the right is attached directly to 2 hydrogens. So in a molecule like this, it doesn't matter where the H in the OH is, because these carbon atoms have the same number of hydrogens directly attached to them. But what about if my alkene doesn't have that case, which is the bottom example that we have here? We have an alkene. In this alkene, we can see that carbon number 2 is directly attached to 1 hydrogen. Carbon number 1 is directly attached to 2 hydrogens. Put a 1 in the chat if you see that the number of hydrogens in carbon number 1 and carbon number 2 are different. Let me label them differently. Say that this is carbon number 2. This is carbon number 1. Great. So this is where carbon number 1 is. This is where carbon number 2 is. Now, notice what happens when there is a difference in the number of hydrogens that are directly attached to a particular alkene that is undergoing hydration reactions. Okay, so the incoming groups that is coming from the reagents is going to be an H and an OH, because we are indeed going to form an alcohol. Now, if we look closely at who gets the H, well, the H goes to the carbon that has the most hydrogens directly attached to it. So if we pay close attention to this, look, carbon number 1 has 1, 2 hydrogens directly attached to it. They're right here. So that incoming H joined them. Remember that the double bond is no longer going to be there. In addition reactions, we're going to remove the second line in the double bond or 2 lines of the triple bond, okay? But in hydration, we only have to be dealing with alkenes, so that's why we're erasing only one of the 2 bonds that are connecting the carbon atoms. Now, when we pay attention to what happened to the OH, we can see that the OH went to the carbon atom, specifically that had the least number of hydrogen atoms attached to it. So be careful when you're predicting the products for hydration reactions, because you need to know how many hydrogens are directly attached to the carbons in the alkene. And then when you're predicting the products, keep that in mind to select the correct product of the reaction, which must be an alcohol. Any questions about hydration or hydrogenation reactions? Any questions about any of the 5 reactions that we talked about? Okay, I don't see any questions on the chat. Specific questions about chapter 6 or chapter 7. As you can see, in chapter 6, we focused on carbohydrates. I will advise you guys that when it comes to the carbohydrates, make sure that you know how to name the alcohols, aldehydes, ketones, all the other information for the alcohols. Make sure that you revise your slides. When it comes to chapter 7, which is when we are looking at attractive forces, okay? Make sure that if you're not familiar with how to determine the polarity of a molecule, you review that, because I know we did that some time ago. But specifically in chapter 7, I gave you guys practice problems in order for you to determine what is the strongest attractive force. And when it comes to the exam, you guys need to, given a Lewis structure, determine the polarity of a molecule, meaning if it's ionic, if it's polar and nonpolar, and based on that, determine the attractive force found in the molecule. Great, since there are no questions, then let me move on and share the Kahoot. So at this time, please just log into the Kahoot. We only have 7 students. Oh, Kahoots have little characters now. That's cool. So you can select your own character. That's new. Oh, I like that the personalities for you guys are showing up when I see these characters. This is so cool. I really like this. We're missing 1 student. Awesome. Great. So at this time, let's get started with Kahoot. Great. Let me see if I can make this larger. Okay, awesome. The sound, there you go. So when we look at this reaction, what is the functional group that we're starting with? Let's put it in the chat. Let's help the 2 students that missed this. What is the functional group that we start with? It's not an aldehyde, it's the cousin. That's not an aldehyde. What is that? Great, that's a ketone. And we can see that the product of that is what? We're going from ketone to what? What's the product here? Great, an alcohol, specifically a secondary alcohol. So remember, when we start with a ketone and we convert it to the secondary alcohol, that is called a reduction. Let's move on to the next question. So for the student that missed this, as you can see, carboxylic acid, amine, overall, we're heating it, we're losing water, we're forming an amide. That's what tells us that this is a condensation. Let's continue. Excellent. So remember, when it comes to oxidation, we are going to be converting a primary alcohol specifically to the aldehyde to the carboxylic acid, and then the secondary alcohol is going to go to the ketone, okay? So the reaction that was described on A, which is carboxylic acid and alcohol converting to an ester, that's a condensation reaction. The amide converting to carboxylic acid and amine, that's actually a hydrolysis reaction. And then the aldehyde converting to the primary alcohol is a reduction reaction. So keep in mind that not only you need to identify the structures, you also need to identify them in words. So that's why we reviewed in the beginning of today's class how to go about recognition of these important organic reactions. Let's continue. There you go. Great job, Nikki. 3 in a row. Great. So as you can see, the two ways to create carboxylic acids, okay, that we have in those reactions is oxidation of aldehydes and also hydrolysis of esters. There's one more. What would be the other way that we can make a carboxylic acid based on the reactions that we have talked about so far? There's one more. It's not here. What is the other way? Let's put it in the chat. One more way that we can make a carboxylic acid. No, it's not the condensation of an alcohol. It's in the hydrolysis. What other functional groups can we hydrolyze to make a carboxylic acid? Thank you, Katie. Exactly. The hydrolysis of an amide is the other way that we know how to make carboxylic acids here. Let's continue. So this is what I was mentioning to you guys. So overall, what we need to remember here is that we start with an alkyne. This alkyne happens to have a bromine in it. So overall, what's going to happen is that where we have the triple bond, each of those carbons are going to have hydrogen. So that triple bond actually turns into a single bond, and each of those carbons have now 2 additional hydrogens. So what happens is that the first group, the CH, turns into a CH3, the next carbon turns into a CH2. That's why the answer is the yellow one. Let's continue. Okay, so when we look at the following alcohol, the carbon that is holding the OH, we can see the connection to one hydrogen. There is another hydrogen that is there. It's just that I decided not to put it, just to remind students of the attachment of the atoms, specifically if we have a skeletal structure that has some atoms in it. But since the carbon that is holding the OH is connected to one more carbon, that's why that alcohol is primary. Great job, Nikki. 6 in a row. I hope you get all 20 correct. Let's continue. Great job, you guys. So remember, here we have only 1, 2, 3, 4, 5. That's why it's called a pentose. And since we have a ketone, that is a ketopentose. Let's continue. Great job, you guys. So, remember that when it comes to this is just straight from the notes. Maltose is a combination of glucose and glucose. Another thing that you guys need to know for the exam is the type of bond, glycosidic bond, that unifies these different monosaccharides. So remember, you guys, that sucralose and Splenda, it is the sweetest, but not monosaccharide, okay? What is the sweetest monosaccharide? Let's put it in the chat. It's not Splenda. Splenda is a carbohydrate-derived sugar. Great job, exactly. Fructose is the sweetest monosaccharide, okay? Let's continue. We're halfway. Great. So when it comes to the polysaccharides, remember that glycogen is highly branched. So out of the two polysaccharides that exist in starch, it actually looks more closely like amylopectin, because amylopectin also has branches. Remember that as part of chapter 6 material, you guys need to know how to name alcohols, aldehydes, ketone, cyclic ketones, and benzaldehydes. And in this one, our longest carbon chain, starting with the CH3 to the left, that's carbon 1. Carbon 2 is the one that is holding the OH. Carbon 3 is the other CH, and then we have to move up to find the longest carbon chain. So make sure that you practice. Great. Just as a reminder, remember that when it comes to sugar alcohols, this is a reduction reaction that we're going to be doing on a monosaccharide or disaccharide. And sugar alcohols have the ending ITOL, okay? So we're going to remove the OSE, and here we have fucose. So we remove the OSE and put ITOL, and that will be the sugar alcohol that comes from this monosaccharide. Great job. Make sure that you guys practice. Let's continue. Great, we have a few more questions to go. We have 3 players with a streak of 4 correct. Great job, you guys. Great. So when it comes to this, make sure that this is specifically, let me see the slide number. So this is the last slide, specifically in the carbohydrate chapter. So this is section 6.7. This is slide 24. Okay. So make sure that you have that handy for the exam. Okay, 5 more questions to go. Okay, let's go over this question. So when it comes to polarity, okay, understand that here we have a tetrahedral molecule that does not have 4 identical groups, okay, around that carbon atom, okay? So a molecule that is tetrahedral and does not have 4 identical groups, then that means that the molecule is polar, okay? Now, that means that if we utilize the flow chart that is specifically on slide on slide 3 of chapter 7, we can determine that this molecule, there's no ions involved, the molecule is polar, and we don't have hydrogens directly attached to a fun element, okay? So because my hydrogen is attached to carbon and not to the fluorine, this is why dipole-dipole attractions is the strongest attractive force here. So remember that for this question in the exam, number 1, you need to determine what is ionic, what's polar, what's non-polar. And based on that, then you can utilize the flowchart on slide 3 of chapter 7 and go through the process of saying or answering the questions. For those of you that actually need to see the slide, let me show it so you guys have a reference. This is the slide that I'm referring to, okay? So this molecule is polar. As you can see, you start by saying interacting molecules or ions, are ions involved? Then the answer is no, because we have a covalent compound, as you can see. Then you have to ask, are the molecules involved polar? Then the answer is yes, so that will take you down. Are hydrogen atoms bonded to nitrogen, oxygen, or fluorine? They need to be bonded to them. Since the answer is no, that's why dipole-dipole is the correct, strongest attractive force that we have in the molecule. So remember, if you're not familiar with Lewis dot, make sure that you review that. Make sure that you know what is ionic, what is covalent. How do I determine the polarity of my molecule? All of those play a role in answering this question in the exam. Okay, let's continue. Nikki regained her streak with 6 in a row. Let's move on to the last few questions. What is the only property that describes a gas that we don't have here? We can see the mass in moles, the temperature in Kelvin, the pressure in millimeters of mercury. Thank you, Katie. Exactly, volume. And understand that out of all of the properties that describe a gas, the only ones that we need a specific unit for them is mass, which needs to be in moles in calculations, even though we didn't do any calculations with moles, and specifically temperature needs to be in Kelvin. Because we did Charles' law calculations, always remember that for Charles' law, even if your temperature is given in Celsius, the first step before you even plug in anything into any equation, change your temperature straight to Kelvin and then use it to solve any Charles' law problems, okay? The pressure can be in any unit, the volume can be in any unit. So when it comes to the two different laws that we learned, the reason why this is false is because volume and temperature is actually Charles' law. Boyle's law compares the relationship of which two of the properties that describes a gas. Which one is Charles' law? Thank you, Katie. Yes, pressure and volume. Volume and temperature is Charles, and pressure and volume is Boyle's, okay? Two more questions to go. Okay, let's go over this problem, okay? So one of the things that we need to know when it comes to this is that when it comes to this type of problem, we're given volume and we're given pressure. So immediately, if there is volume, and you know that you have volume because you have liters, and we have pressure because we have the unit of ATM, okay? The problem also says volume and pressure. Immediately through your brain, you run for Boyle's law, okay? So taking into account that we have Boyle's law, we need to remember that the equation is P1 times V1 equals P2 times V2. Since we have to calculate the final pressure, what we need to do is multiply 18.0 times 5.65 and divided by 12. Another thing that we need to keep in mind is that there was one answer that should not be the answer that we select, right? Remember that because pressure and volume are inversely proportional, and we know that the volume compressed, meaning that it lowered, that means that the pressure is going to be higher than 5.65. So that's why the blue answer makes no sense. Then when you actually do the calculation, when you need to pick between the red, the yellow, and the green one, that's why the red one is the correct one, okay? And let's go to the last question. Great. So here we have an unsaturated fatty acid. When we're trying to determine the omega term, is going to be the first carbon in the carbon-carbon double bond when we start numbering it from the CH3 end. So here we have carbon 1, carbon 2, 3, 4, 5. The sixth carbon is the first carbon in the carbon-carbon double bond. That's why this is an omega 6. And this is our podium. There you go. Great job, you guys. I am so proud of you guys. I hope that this review helped you guys to study for the exam and get ready. And remember that you could take it either tomorrow, Saturday, or Sunday. I will be opening it again, Friday, Saturday, and Sunday. And this is, unless there's any other questions, this is all for today. You're welcome. Since there are no questions, this is where today's review stops.